A very powerful property of vector quantities is that they can be added together to figure out what the sum of several like-kinded vectors is. Let's look at an example of this. Let's just imagine that the green dot is just your couch in your apartment, and you and your roommates are having an argument about where the couch should be. Well, let's just imagine that roommate A would like the couch to go there. So they're going to press with a force of magnitude this vector in this direction to try to move the couch that way. We'll just call that vector A. All right. Roommate B thinks the couch ought to go in that corner, and he's going to push harder in that corner with force B. And then roommate C thinks the couch ought to go in, let's say, this corner down here, and they're going to push with magnitude C. Okay, so the question is, in what direction is the couch actually going to move? Well, since these are vectors, we can just add them up in the following way. We can just use a technique called the tip-to-tail addition technique, which is just visually represented by this. If the green dot is representing where the couch is going, let's figure out where all these vectors add up, and that's going to be the direction that the couch actually moves. So all we're going to do is take the vector B, put the tail of vector B to where the tip of tail or vector A ends, and just drop it off right there. Let's do the same thing for vector C. Let's move that right there. So now what we have is our vector sum starting at the location there and ending at the tip of vector C. So the resultant vector is going to start where our vector A began and end where our vector C ends. So what we have here in red is the vector A plus B plus C. That's how you can add vectors up. Okay? All right, so a really popular question at this point is, does it matter in what order you add the vectors, A plus B plus C? Well, let's investigate this. Okay, so let me just remove a resultant that we drew there. And let's retain our starting green point and our ending red point. And let's just cut and paste these vectors in a different order. Right? Okay, so I'm just going to move vector A out of the way here. Move vector B out of the way over here. And let's just use vector C as our starting point right here. Okay, so now let's start by adding vector C, and let's add to that vector B, and then add to that vector A. And you could see that we end up with the exact same resultant, now starting at the tail of vector C and ending at the tip of vector A. So symbolically, we could represent this as vector C plus vector B plus vector A. And that is equivalent to the vector that we calculated previously, A plus B plus the vector C. If you recall from your algebra class, that property is the commutative property